The problem goes, three-digit numbers have consecutive hundreds digits and their units digit is one more than the hundreds digit. If the hundreds digit of the smallest number is n, and all of the numbers has 0 as their tens digit, what is the sum of the three numbers? Okay, so let's try just to write here, the three numbers, the second of the three-digit number, and the third. Okay, now what is cool about this problem is that it gives relationship between the digits, and well, let us see. Let us say that this is the smallest. Okay, shall we say this is the smallest among the three numbers? And according to the problem, the hundreds digit, if the hundreds digit of the smallest number is n, so note this is the ones, tens, and the hundreds, so this must be n. And according to the problem, all of the numbers has 0 tens digit, so all of the middle numbers is actually 0. And according to the problem again, that the ones, they call that, have, and their units digit is one more than the hundreds digit. So meaning, if this is n here, the hundreds digit, the units digit will be most likely n plus 1, right? Because it's one more than that. Okay, so these are of course a three-digit number all in all, but the relationship is that n, if this is n here, this will be n plus 1 here. Now the problem goes further that the hundreds digit are in consecutive order, meaning if this is n here, we can say that the next hundreds digit will be n plus 1, and of course it will follow that the units digit for this case will be n plus 1 plus 1, which is n plus 2. Just add 1 to this one. In this case, this will be n plus 2 here, and then this one will be n plus 3, right? Because we need to add 1 to this hundreds digit to get the units digit. Now, what is the sum of these three numbers? We are asked now to do the sum. By the way, in getting the sum, we need to represent this three-digit number. How do we represent this as an expression, an algebraic expression? So by the way, if you have a number like 352, you express it, because if we just put variables to this, we can thought of this are being multiplied to each other, but it's not really, right? In base 10, this will mean 3 times 100 plus 5 times 10 plus 2 times 1. So that's why we get a 352. So for this case, this will just be n times 100, or 100n, plus 0 times 10, plus n plus 1. Okay? So this is the first number. Okay? The second number, which will be this one in red, will be n plus 1 times 100. Okay, let me just make it like this. So 100 times n plus 1, and then here plus n plus 2 times 1, which is the units digit. And lastly, for the other group, you will have here a quantity 100 times n plus 2 plus n plus 3. Okay, and it's just a matter of simplifying now to get the final answer. Okay, let me just, this is the sum, okay? Sum of the digits. Now, let me just simplify 100n plus n plus 1 plus here you do 100n plus, okay, here 100n plus 100, so properly distribute the 100 plus n plus 2, and lastly 100n plus 200, okay, plus n plus 3. And now we combine all the like terms. So 100, what is this? 100 and another 100, another 100, that's 300n plus 3n. So all in all, that's 303. Okay, all in all, that's 303 n, and the constants 1, 2, 3. That's a what? For the constant part, 1 plus 2 plus 3 is 6, and then plus, what's this? Plus 300. So you have plus 306. Okay, so the sum of the three numbers will be 303n plus 306. Okay, that's good.